हेलो दोस्तों, बिगनर्स माइंड में आपका स्वागत है। अभी हम कर रहे हैं इकोनॉमिक्स और चैप्टर है नंबर 6 को रिलेशन। इंट्रोडक्शन। इन प्रीवियस चैप्टर्स यू हैव लर्न how to construct summary measures out of a mass of data and changes among similar variables. Now you will learn how to examine the relationship between two variables. As the summer heat rises, hill stations are crowded with more and more visitors. Ice cream sales become more brisk. Thus, the temperature is related to number of visitors and sale of ice creams. Similarly, as the supply of tomatoes increase in your local mandi, its price drops. When the local harvest starts reaching the market, the price of tomatoes drops from rupees 40 per kg to rupees 4 per kg or even less. The supply is related to price. Correlation analysis is a means for examining such relationships systematically. It deals with questions such as, is there any relationship between two variables? एक तो यहाँ पे फोटो वगैरह कुछ होगी वो शो नहीं हो रही, चलो छोड़ो। टाइप्स ऑफ रिलेशनशिप। Let us look at various types of relationship. The relationship between movements in quantity demanded and the price of commodity is an integral part of the theory of demand, which you will study in class 12th. Low agricultural productivity is related to low rainfall. Such examples of relationship may be given a cause and effect interpretation. Others may be just coincidence. The relationship between the arrival of migratory Pravasi migratory birds in a sanctuary and the birth rates in the locality cannot be given any cause and effect interpretation. Migrate मतलब जो इधर से उधर भटकते रहते हैं, एक जगह से दूसरी जगह birds वगैरह. The relationships are simple coincidence. The relationship between size of the shoes and money in your pocket is another such example. If even if relationships exist, they are difficult to explain it. In another instance, a third variable's impact on two variables may give rise to a relationship between the two variables. Brisk sale of ice creams may be related to higher number of deaths due to drowning. The victims are not drowned due to eating of ice creams. Rising temperatures leads to brisk sale of ice creams. Moreover, large number of people start going to swimming pools to beat the heat. This might have raised the number of deaths by drowning. Thus, temperature is behind the high correlation between the sale of ice creams and deaths due to drowning. What does correlation measures? Correlation studies and measures the direction and intensity of relationship among variables. Correlation measures covariation, not cautions. Correlation should never be interpreted as implying cause and effect relation. The presence of correlation between two variables x and y simply means that when the value of one variable is found to change in one direction, the value of the other variables is found to change either in the same direction, that is positive change, or in the opposite direction, that is negative changes, but in a definite way. For simplicity, we assume here that the correlation, if it exists, is linear, that is, the relative movement of the two variables can be represented by drawing a straight line on a graph paper. Types of correlation. Correlation is commonly classified into negative and positive correlation. The correlation is said to be positive when the variables move together in the same direction. When the income rises, consumption also rises. When income falls, consumption also falls. Sale of ice cream and temperature move in the same direction. The correlation is negative when they move in opposite directions. When the price of apples falls, its demand increases. When the prices rise, its demand decreases. When you spend more time in studying, chances of your failing decline. When you spend less hours in your studies, chances of scoring low marks, grades increases. These are instances of negative correlation. The variables move in opposite direction. Techniques for measuring correlation. Three important tools used to study correlation are scatter diagrams, Carl, Carl Pearson's coefficient of correlation, and Spearman's rank correlation. A scatter diagram visually presents the nature of association without giving any specific numerical value. A numerical measure of linear relationship between two variables is given by Carl Pearson's coefficient of correlation. A relationship is said to be linear if it can be represented by a straight line. Spearman's coefficient of correlation measures the linear association between ranks assigned to individual items according to their attributes. Attributes are those variables which cannot be numerically measured, such as intelligence of people, physical appearance, honesty, etc. Scatter diagram. A scatter diagram is a useful technique for visually examine the form of relationship without calculating any numerical value. In this technique, the values of the two variables are plotted as points on a graph paper. From a scatter diagram, one can get a fairly good idea of the nature of relationship. In a scatter diagram, the degree of closeness of the scatter points and their overall direction enable us to examine the relationship. If all the points lie on line, the correlation is perfect and is said to be is unity. If the scatter points are widely dispersed around the line, the correlation is low. The correlation is said to be linear if the scatter points lie near a line or on a line. Scatter diagrams spanning over figure 6.1 to figure 6.5 give us an idea of the relationship between two variables. Figure 6.1 shows a scatter around an upward rising line indicating the movement of the variables in the same direction. When x rises, y will also rise. This is positive correlation. In figure 6.2, the points are found to be scattered around a downward sloping line. This time the variables move in opposite directions. When x rises, y falls, and vice versa. This is negative correlation. In figure 6.3, there is no upward rising or downward sloping line around which the points are scattered. This is an example of no correlation. In figure 6.4 and figure 6.5, the points are no longer scattered around an upward rising or downward falling line. The points themselves are on the lines. This is referred to as perfect positive correlation and perfect negative correlation respectively. A careful observation of the scatter diagram gives an idea of the nature and intensity of the relationship. Carl Pearson's coefficient of correlation. This is also known as product moment correlation coefficient or simple correlation coefficient. It gives a precise numerical value of the degree of linear relationship between two variables x and y. It is important to note that Carl Pearson's coefficient of correlation should be used only when there is a linear relation between the variables. When there is a non-linear relation between x and y, then calculating the Carl Pearson's coefficient of correlation can be misleading. Thus, if the true relation is of the linear type as shown by the scatter diagrams is 6.1, 6.2, 6.3, 6.5, then the Carl Pearson's coefficient of correlation should be calculated and it will tell us the direction and intensity of the relation between the variables. But the true relation is of the type shown in the scatter diagrams in figure 6.6 or 6.7, then it means there is a non-linear relation between x and y, and we should not try to use the Carl Pearson's coefficient of correlation. It is therefore advisable to first examine the scatter diagram of the relation between the variables before calculating the Carl Pearson's correlation coefficient x1 x2 say xn. The n values of x and y and to yn be corresponding values of y. In the subsequent presentations, the subscripts indicating the unit are dropped for the sake of Simplicity. The arithmetic means of x and y are defined as x sigma x upon n, y sigma y upon n. ये है पॉजिटिव पॉजिटिव कोरिलेशन, ठीक। ये नेगेटिव और ये नो रिलेशन, कोई भी रिलेशन कोरिलेशन नहीं है। परफेक्ट पॉजिटिव कोरिलेशन और परफेक्ट नेगेटिव कोरिलेशन। पॉजिटिव नॉन लीनियर, ये लाइन होती है इसलिए लीनियर होता है ये, ठीक है। ये पॉजिटिव है, ऐसे ही ये लीनियर कोरिलेशन हो जाएगा। इसमें कोई सीधी लाइन नहीं है, इसलिए क्या हो जाएगा, नॉन लीनियर रिलेशन। ऐसी नेगेटिव नीचे की साइड आ रहा है, एक्स एक्सिस बाई एक्सिस से एक्स एक्सिस साइड आ रहा है तो ग्राफ में उल्टा दिखा रहा है इसलिए नेगेटिव, और पॉजिटिव क्योंकि चढ़ता हुआ है। ऐसे इसमें परफेक्ट, एकदम परफेक्ट है, ये डॉट डॉट है इसलिए परफेक्ट, परफेक्ट पॉजिटिव कोरिलेशन और नेगेटिव कोरिलेशन, ठीक। इसके बाद एंड देयर वेरिएंस हैज फॉलोज, ये फॉर्मूला हो जाएगा इसका, एक ये फॉर्मूला हो जाएगा, द स्टैंडर्ड डेविएशन ऑफ एक्स एंड वाई रिस्पेक्टिवली आर द पॉजिटिव स्क्वायर रूट्स ऑफ देयर वेरिएंसेस। कोवेरियंस ऑफ एक्स एंड वाई इज डिफाइंड एज कोवेरियंस एक्स एंड वाई, ये पूरा फॉर्मूला हो जाएगा। डेविएशन ऑफ आई value of x and y from their mean values respectively. The sign of covariance between x and y determines the sign of the correlation coefficient. The standard deviations are always positive. If the covariance is 0, the correlation coefficient is also 0. The product movement correlation or the Karl-Pearson's measure of correlation is given by R sigma xy and neutral x xy. Properties of correlation coefficient. Let us, ये दोनों इसके फॉर्मूले हो जाएंगे, ठीक है। R has no unit. It is a pure number. It means units of measurement are not part of R. R between height in feet and weight in kilograms. For instance, could be say zero point 0.7. A negative value of R indicates an inverse relation. A change in one variable is associated with change in the other variable in the opposite direction. When price of a commodity rises, its demand falls. When the rate of interest rises, the demand for funds also falls. It is because now funds have become costlier. If R is positive, the two variables move in the same directions. When the price of a coffee, a substitute of tea, rises, the demand for tea also rises. Improvement in irrigation facilities is associated with higher yield. When temperature rises, the sale of ice cream become bricks. The value of the correlation coefficient lies between -1 plus and +1. -1 is smaller than R and R is smaller than 1. If in any exercise the value of R is outside this range, it indicates error in calculation. The magnitude of R is unaffected by the change of origin and change of scale. Given two variables x and y, let us define two new variables, ठीक, u x minus a divided by v y minus c divided by d. A or c are assumed means x and y represent respectively. B and d are common factors and of same sign, r xy or r uv. This property is used to calculate correlation coefficient in a highly simplified manner, as in the step deviation method. If r equals to 0, the two variables are uncorrelated. There is no linear relation between them. However, other types of relation may be there. If r is equal to 1 or r is equal to -1, the correlation is perfect and there is exact linear relation. A high value of r indicates a strong linear relationship. Its value is said to be high when it is close to +1 or -1. A low value of r close to 0 indicates a weak linear relation, but there may be a non-linear relation. As you have read in chapter 1, the statistical methods are no substitute for common sense. Here is another example which highlights the need for understanding the data properly before correlation is calculated and interpreted. an epidemic spreads in some villages and the government sends a team of doctors to affected villages. The correlation between the numbers of deaths and the numbers of doctors sent to the villages is found to be positive. Normally, the healthcare facilities provided by the doctors are expected to reduce the number of deaths, showing a negative correlation. This happened due to other reasons. The data relate to a specific time period. Many of the reported deaths could be terminal cases where the doctors could do little. Moreover, the benefit of the presence of doctors becomes visible only after some time. It is also possible that the reported deaths that death are not due to the epidemic. A tsunami suddenly hits the state and that toll rises. Let us illustrate the calculation of R by examining the relationship between years of schooling of farmers and annual yield per acre. कितना हो जाएगा per per acre? Example, number of years of schooling of farmers, annual yield per acre in 00 कितना, ये थाउजेंड्स। दो का कितना है 4000, चार का छः, छः का 10,000, ऐसे ही पूरी टेबल है। थ्री फार्मूल वगैरह लगाया है और आंसर क्या आ जाता है इसका, √38 डिवाइड बाई 7। फिर ये पूरा कैलकुलेट करके 10 years of education of farmers and annual yield per acre are positively correlated. The value of R is also large. It implies that more the number of years farmers invest in education, higher will be the yield per acre. It underlines the importance of farmers education. ठीक है, अभी आगे का करेंगे अब कल।